Hello students, now we have to discuss our experiment number 8 of electrical maintenance 2. The aim of this experiment is to perform calibration of DC ammeter. So as we have seen in experiment number 7, the calibration of voltmeter, that we determine the error in the readings of a voltmeter. In the same way, in this experiment, we have to determine error in the readings of a DC ammeter. So, for this experiment, we will require following list of apparatus. We will use DC supply, that is said to be a DC regulated power supply of specification 0 to 30 volt, 2 amperes. So, this DC regulated power supply will make us available a DC supply to circulate a DC current in the circuit for the measurement. We will use DC ammeter to measure the magnitude of DC current of the range 0 to 5 ampere, and that we will use in the quantity 2. Out of this 2, we will treat one of the ammeter as a standard ammeter, which will be pre-calibrated with the help of potentiometer. So we can also say it as a substandard meter, and one will be the meter which we will treat as a faulty in order to find out the error in the reading of that meter. We will use some connecting wire for making the connection of a circuit. We will use 1 square mm PVC insulated copper wire as per the requirement. And in this experiment, we will use a load having the value of resistance around 20 ohm. We can also vary the load condition, and we will use in the quantity 1. So, as for this practical, we can see that 0 to 5 ampere ammeters are needed, but we can also use the different range ammeter for finding out the error in the reading of the meter. So let us have a look at the circuit diagram of this experiment. So for the experiment, first of all, we will need single phase 230 volt 50 Hz AC supply, which we can easily take from the switchboard which is available in the lab. Then with the help of IC/DC switch, we will connect the AC input, that is phase and neutral, to the DC regulated power supply. This DC regulated power supply will first perform the task of converting AC into DC, and across the output terminals of a DC regulated power supply, which will be marked as a positive and negative terminal, we can take output DC current for the measurement of a current. So the positive terminal or positive output of DC regulated power supply, we have to connect it to the positive of one of the ammeter. So within the circle, I have written as AS, and there is a straight line below that. This straight line is an indication that the meter which we are using is a DC ammeter. So we have to keep in mind that positive output of the regulated power supply is to be connected to the positive of the ammeter, because for measurement of the current we have to connect ammeter in series. Next, negative terminal of AS ammeter will be connected to the positive of another ammeter which is written as AS, and negative of the AS will be connected to the load. So for this experiment, as we know that we have to measure some current, we have to find out the readings in ammeter. So obviously we will require some load, and we will be using a lamp load or a load which is having a resistance value of around 20 ohms approximately. So we will connect the negative terminal of AS to the positive terminal of the load, and at last the negative of the load will be connected to the negative of the DC regulated power supply. So this will complete our circuit, and as we know that for the flow of current, the closed circuit is required. So we will require some load in order to circulate the current through the ammeter. So load will consume power and that current will be indicated in both the ammeters. So here AS, which is already pre-calibrated with the help of potentiometer method, we will say it as a standard ammeter, or we can also say it as a substandard ammeter. And AF will be the meter in which we have to find out the error in its reading. So we will treat this meter as a faulty ammeter. So with this description of circuit diagram, now let us have a look at the apparatus for this experiment. So for this practical, the first device that we will be DC regulated power supply. It is the same regulated power supply that we have used for calibration of DC voltmeter. Now in the same way, we will be considering the two output terminals, that is one positive and negative, from where we will be getting DC output, and we will connect load across this output terminal. And with the help of the current variation knob, we will apply the variable current through the load. Next, we will be using two ammeters, as we can see here, that below the A there is a straight line that is indicating DC ammeter. For our experiment, we will be using an ammeter which is having a maximum range of 0 to 2. We can also use ammeter having the range of 0 to 5, or for any range we can perform this experiment. So for our purpose, we will be using ammeter which is having a scale range of 0 to 2 ampere. Now observing the scale carefully, we can see that the pointer or the first scale is starting from the 0, then it is directly indicating an deflection of 0.5 ampere, then 1 ampere, 1.5 and last 2. So between the 0.5 there is one bigger scale we can see, and each and every small deflection is actually here indicating a current of 0.1 ampere. So each and every small deflection will indicate a rise in the current of 0.1 ampere. So it is up to the maximum value of 2. Now as we have to connect the load, so as a load we will use a lamp load, and it will be having two connecting wires, one to be connected across the positive of the regulated power supply and other one to be connected across the negative of the power supply. So let us go through the connection and how to take the readings for this experiment. So for this practical, students, firstly we will connect the main incoming wire that is to be connected to single phase AC supply across the switchboard, and we have to make sure that the off push button is in the off position and voltage variation and current limiting knob are in the 0 position. So firstly we have to connect an ammeter. So we will treat the first one ammeter as the standard which has been calibrated earlierly. So we will connect the positive terminal of the ammeter to the positive output of the regulated power supply. Then the current will come out from the negative terminal. So we will connect another ammeter that we have to treat it as a faulty to the positive terminal. So negative of the ammeter 1 is connected to the positive of the ammeter 2. Then negative of our faulty ammeter or ammeter 2 we will connect to the positive or incoming supply wire of our load. So we will make this connection, and at last we will make the connection of negative terminal of the load to the negative terminal of the power supply. Now for this practical, firstly we will switch on our DC regulated power supply, making sure that the voltage applied is 0. Then with the help of a current limiting knob, we will increase the magnitude of the current and we will apply the current through the load. So for the switching on of the load, the ammeter AS and AF will show deflection. So we will take multiple readings of both the ammeter for increasing magnitude of the current with this knob. So first we will take, let us say, at a reading of 0.5 ampere, then 1 ampere, then 1.5 and last reading at 2 ampere. So for each and every reading we will note down the readings of both the ammeter and that we will calculate in the calculation the error which will be involved between these two readings of the ammeter by using the formula AS minus AF. So let us have a look at the observation table and understand the calculation part. So in this experiment we have to prepare the observation table for standard ammeter reading, faulty ammeter reading, error that we have to calculate from readings of AS and AF by using the formula AS minus AF. Then percentage error that we have to calculate by using the formula AS minus AF divided by AS multiplied by 100 for each and every reading. So in our experiment, as we were using an ammeter of 0 to 2 ampere range, so we can reflect the readings of standard ammeter for the variation of current that we applied with the regulated power supply, and we can note down the faulty ammeter reading in the column of faulty ammeter. So for the first reading, that is of 0.5 ampere read by standard ammeter, the reading of faulty ammeter is to be indicated as 0.3 ampere. So for the first reading, we have to calculate the error as AS minus AF. So we can calculate it as 0.5 minus 0.3, that will give us 0.2 ampere. So this error calculation and percentage error calculation for each and every reading, we have to reflect it in the calculation part. By doing their calculation, we have to reflect the error value and percentage error value in the observation table. For the second reading, which is for AS is 1 ampere and AF is 0.8 ampere, so it will 1 minus 0.8, we will again get 0.2 ampere. For third reading as well, 1.5 minus 1.3, we will get the error of 0.2 ampere. For last reading, that is 2 minus 1.8, we will get AS minus AF equal to 0.2 ampere. So for this case as well, we get the error of a constant value throughout the range of the ammeter. So from this value of error, we will do the calculation of percentage error in calculation part for each and every reading. In calculation, we have to perform two types of calculation for each and every reading. In this experiment, first for reading number 1, we will calculate error that will be given by standard ammeter reading minus faulty ammeter reading. So for first reading, that is 0.5 minus 0.3, we will get the value of error equal to 0.2 ampere. So here we are getting the value of error as a positive. Now we will calculate the percentage error by the using formula, that is AS minus AS divided by AS multiplied by 100. So as we have already calculated AS minus AS, which is 0.2, so divide by standard ammeter reading, that is 0.5 multiplied by 100. The percentage error for the first reading we get to be 40%. Same calculation we have to perform for reading number 2. For reading 2, we will calculate the error AS minus AS, that is for second reading 1 minus 0.8, so it will give us 0.2 ampere. So this error for second reading, we have to reflect it in observation table in the second column. So basically we will calculate percentage error for the second reading by using the same formula, AS minus AF by AS multiplied by 100. So for second reading, 0.2 divided by 1, that is AS reading in second case, we get the percentage error of 20%. Performing same calculation for reading number 3, the error will remain constant, that is 0.2. For reading 3, we will find out that the percentage error will become less and we will be getting it as 13.33%. For reading number 4, we will calculate error, which will be again same, that is 0.2 ampere, and percentage error for reading 4 is further reduced and it has become to 10%. So in this experiment, according to the readings of standard ammeter and faulty ammeter, we have noted that the error is constant for each and every reading, that we have to reflect it in the observation table. Then percentage error is decreasing with the increasing magnitude of the current. So basically this percentage error calculated value, we have to reflect it in the observation table as well. Now for this experiment also, we have to plot two graphs. So let us go through the nature of the graph that we have to plot for this experiment. So in this experiment, we have to plot two graphs on the graph paper. First graph we have to plot is the graph of standard ammeter reading versus faulty ammeter reading. For plotting this graph, we have to carefully observe standard and faulty ammeter reading in the observation table for their positive or negative values. As in our experiment, we are getting both the values as positive. So we have to take standard ammeter reading on x-axis and faulty ammeter reading on y-axis. We have to select a suitable scale that on x-axis 1 centimeter is equal to how much ampere. This will depend on the values of the reading that may change according to the batches. So for example, here we will take on x-axis 1 centimeter is equal to 0.1 ampere. On y-axis we are taking faulty ammeter reading, so we will take it as 1 centimeter is equal to 0.1 ampere. So it may happen that both the scale range may change depending on values of reading. So for this scale, we will mark on the graph paper, that is 0.1, then 0.2, then 0.3 and so on. Same on the y-axis, starting from 0.1, 0.2, 0.3 and so on, and going through the readings of the observation table of AS and AF. For first reading, we will plot a point depending on both the readings. For second reading, we will plot the second point. For third reading, we will plot the third point. And for fourth reading, we will plot the fourth point. So there is no need to reflect the coordinates on the graph, just we will circle up the points. So these points are to be plotted according to values of AS and AF. I am showing you just an example. At last we have to join this point. So as we have also observed from the observation table that with the increase in the reading of AS, AF reading is also increasing in the positive direction. So we will get the nature of the graph nearly by to straight line. So this is the first graph that we have to plot. The second graph that we have to plot is the graph of standard ammeter reading versus percentage error. For this graph, again we have to take standard ammeter reading on x-axis and percentage error reading on y-axis. But here we have to keep in mind that whatever percentage error which we are getting from the calculation, either it is positive or negative. For our calculation for this experiment, we got the percentage error as positive, and therefore now we will take the axis of percentage error in the positive direction. So we have to keep that in mind, and accordingly we have to consider we have to take the coordinate. So we will write here scale. So on x-axis we will take 1 centimeter is equal to 0.1 ampere. So this is just an example I am saying. We have to consider it according to our values. And on the y-axis, that is percentage error, we will take 1 centimeter is equal to, let us say, 2%. So we will mark these points across the 1 centimeter on the x-axis as well as on the y-axis of the percentage error. Now from the observation table, it is very much clear that in the calculation part we have calculated percentage error for each and every reading, and we have noted that with the increase in the ammeter reading, the percentage error value is reducing. So according to that values, we will plot the points. For the first reading we get the highest value of percentage error. For second reading we got the percentage error reduced, standard ammeter reading increasing. For third value we get decrease in percentage error and increase in AS value. For fourth we will get the fourth point. So we have to plot 4 points for the 4 readings, and then we have to join these points and complete the graph. So the nature of the graph will look like this while plotting on the graph paper. Let us go through the result and conclusion that we can draw from this experiment. So in this experiment, in the result part, we have to write the error of the given ammeter is either positive or negative, and according to the readings which we have seen in the observation table, we got the value of error as a positive. So we will write here that the error in the given ammeter is positive. And in the conclusion, we have to draw the conclusion whether the faulty meter which was in a practical, whether it is reading slow or fast. So as we have observed from the observation table that the reading of the standard ammeter is greater than reading of the faulty ammeter. So for our experiment, we will come to the conclusion that the faulty ammeter is reading slow because it is showing the values of reading lesser than the standard ammeter reading. But this case may be changed. In some cases it may happen that the standard ammeter reading is lesser than the faulty ammeter reading. So in that case, in the conclusion part we have to write that the faulty ammeter is reading higher value than standard ammeter, and therefore ammeter is fast. So this is the changes that we have to remember according to the meter readings that we note down in the observation table.